Hey, okay. Okay, so 3, 2, 1, we're there. Okay, so as we've been doing all these quadratics, I've taught you a lot of things. I've taught you how to factor easy ones, where the a is 1, x squared plus, 8x plus 15. You would know how to immediately put your parentheses and factor. But that only works when it's factorable, right? And I taught you how to use Gary's terrific trick. But it doesn't always work, Gary's terrific trick, because they don't always factor easily, right, with whole numbers. So you can't use that all the time. So then when you're trying to find the zeros, or where a parabola crosses the x-axis, there's only one way that you know right now that always works, and it's called completing the square. Always works. However, sometimes you'll notice that you get a no solution, which means your parabola never crosses the x-axis. It's still a parabola, it just doesn't cross the x-axis, right? So, completing the square, I don't know who figured it out. I think it's a pretty brilliant idea, the way they figured it out. I would never have figured that one out on my own. But some people started saying, well, look, this is kind of weird. We're taking all these problems and we're doing the exact same process, all to get down to x equals, right? And why do we have to do all that work by completing the square and taking the square root of both sides and whatever, and just to get to x equals? Could we take the formula itself of a quadratic equation, the formula, y is equal to ax squared plus bx plus c. What if we solved that formula, right, without real numbers, just with letters? What if we solved that formula all the way down to x equals? Then we'd have a formula that we could just plug numbers into, and immediately know what x equals. Does that make sense? Mm-hmm. Right? So that's what they started, that's what some mathematicians started thinking about. And they said, okay, well, a typical equation says y, let's see, I'm going to have to, where am I? I'm going to start over here. Y is equal to ax squared plus bx plus c. So instead of using numbers, we're going to keep them as variables. And so we are actually going to complete the square using this formula, okay? You don't have to take notes. If you want to, you can, but you don't have to, because it'll be on the video if you need it. The most important thing is that you understand the concept of completing the square, and you can help me figure out what to do, right? Because you're not going to need to necessarily do this again, right? So first of all, completing the square, it always has to equal what? 0 before I know what to do, right? So I'm going to make my y 0, because that's what I'm trying to find. I'm trying to find when y is 0, what are x's? So I'm going to make it equal to 0, but I like my 0 on the right-hand side, so I'm just going to rewrite it as ax squared plus bx plus c equals 0, right? And then Abby, what was the first step you did on that problem when there was a 5 and the a was a 5? You divided everything by 5, right? A has to be 1, but I don't know if a is 1. So I have to divide everything by a. Do you agree with me? Make sense? See what I'm doing? So I'm going to divide this by a, divide this by a, divide this by a, divide this by a. You with me? It's going to get more complicated. It's going to get a little confusing for a while. Well, what happens here? The a's cross out. That's good. So now we have x squared plus b over a x plus c over a is equal to 0. Okay, you with me? We're getting there. Now what do I do to complete the square? What do I have to get rid of? Yeah, the c over a, right? That's got to be moved over to the other side. So I'm going to subtract c over a from both sides. Subtract c over a, and that gives me an x squared plus b over a x plus space equals negative c over a plus space. You guys agree with me? Aren't you glad you're not doing this? Right? So now I got to find my space. What goes in my space? Half of b over a. How do I do half of b over a? Well, half is 1/2. Of means what? Multiply. Half of b over a.
I was right.
So it's b over 2a. You guys agree with me?
Oh, and then are you going to get negative b over 2a?
Yeah, eventually, yeah. So we got b over 2a, right? Oh, wait, excuse me. I'm sorry. Over here. This is b over 2a, right? Positive. B over 2a. That's what I circled. Remember that? And so now I got to square this. So what does that give me? That gives me b squared over, what's 2a squared? 4a squared, right? 4a squared. You guys with me? Okay, I added that to this side. I got to do it over here. B squared over 4a squared. Okay, now what do we got to do? We know we can factor this side. That's real easy because it's just going to be x plus this squared, right? Remember that? That's why I circle that thing there. So suddenly I've got x plus b over 2a squared equals, okay, now this is a mess. I'm going to get rid of my little line there because it just makes it look confusing. I'm going to get rid of this little line now. Okay, so I have two fractions and I have to add them together. What do you have to add fractions together? Common denominator. So let's off to the side.
Multiply by 4.
Let's off to the. Whoop, that was my line. I needed that. So let's just do that over here. We've got since that's a negative, I'm going to flip them. I'm going to put this one first and then put that after it. So let's say we've got b squared over 4a squared minus c over a. What would my denominator have to be over here? 4a squared, right? So what would I have to multiply this a by to turn it into 4a squared?
4 squared.
Say it again?
4 squared.
Well, 4a,
Oh,
right?
yeah.
Just a 4 times an a would give me 4a squared. Do you agree with me? So I'm going to multiply the top and the bottom by 4a, right? So suddenly that gives me b squared over 4a squared minus 4ac, right? 4a times c is 4ac all over 4a squared, 4a squared. Oh, great. So now I have the same denominator. I can just combine my numerators. You agree with me? And put it all under that same denominator?
4abc.
So suddenly I've got this. I have b squared minus 4ac all over 4a squared. Am I right? 4a squared. You guys agree with me so far?
Mm-hmm.
Kind of a nightmare. But believe it or not, we're almost done. This is amazing. Watch this. We square both sides. Square root, I mean. Both sides. So suddenly, I'm going to erase this part so I have room to move up here. So on this side, the square root gets rid of the square. So I just have this. I've got x plus b over 2a. And then equals, I have plus or minus, you guys agree with me? Plus or minus. Now, I can't, this is the same as this. This right here is the same as this. The square root of b squared minus 4ac all over the square root of 4a squared. You see how it's okay to separate them like that. Now, I can't do anything with this. I can't simplify that any further because there isn't a square root, perfect square of this.
The square root of 4a is
But I could,
2a.
yeah, that's 2a, right? Square root of 4 is 2.
Wait, here.
Square root of a squared is a. Yeah.
So after we ended up getting b squared minus 4ac,
Yeah.
what did we do after that? Did we make it into like a foil problem kind of
we put it over here, over the 4a squared, because that was our denominator, right? So we didn't FOIL anything. All we're doing now, so look up here. So we took this, we got a common denominator, and it gave us this. By getting a common denominator, we added them, right? Or subtracted them, right? And then we square root both sides, and we find, this denominator could be 2a, right? So suddenly we've got plus or minus the square root of b squared minus 4ac all over 2a. You with me? We're almost there, guys. We're like 2 steps away from having it. So suddenly, what's my next step? It's got to say x equals. Yeah, I got to subtract this. So subtract b over 2a, subtract b over 2a. Oh, that's interesting. Do they have the same denominators?
Yeah.
Oh, so that means I could do my negative b up on in the numerator, and I could have just the 2a in the denominator. So suddenly that gives me this. X is equal to, I'm going to put my negative b plus or minus the square root of b squared, b squared minus 4ac all over 2a. Ladies and gentlemen, that is the quadratic formula.
That is
That is scary.
horrible.
It looks scary. I agree with you.
Is anybody absent today?
What?
Is anybody absent today?
I don't know. Is anybody absent today?
Horrible. I feel so bad.
This is a lousy marker. This is a little bit better. I'm going to keep going until I get a color that's strong. Well, actually, I'm going to stop because that's my last color. Right? Okay, that is the quadratic formula. The quadratic formula. Okay? Let me just see if I can get. Okay. So can I erase all this garbage now?
Yes.
We created, by completing the square, we went from this, a standard quadratic equation with no numbers, just variables, and we turn it into something that says x equals, which is the final answer that we always want. We want it to say x equals.
Wait, I have a
So,
question.
yes.
I'm confused. Where did the 2a, like when you subtracted the b over 2a, where did the 2a go?
So think about it. If you have this fraction minus this fraction, all I did is since they had the same denominators, I combined them. I combined the numerators and put them all under the same denominator. Just like if I had done, 6.
Oh, because they have like the same denominator, so it's
Right,
just like,
exactly. So I just put the same
So it
denominator
doesn't
there.
really affect it.
Right, exactly. Right? So now, the question is, how is this useful? How do you use this? And since we derived this by completing the square, and completing square always works for every quadratic equation out there, always works, no exceptions.
So you plug it in.
This will also work, no exceptions. So now the question is, how do we use it? You have to memorize this, and it's not that hard. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Sounds like a nightmare. I agree with you. When I first saw it, I thought it sounded like a nightmare. This is now, many people skip the completing the square altogether. Many people often just jump to this because it's really not that hard. It does require a little math, but it's not It's not horrible. Nate prefers this to completing the square. He never uses completing the square. He only uses this, right? I disagree. I use completing the square on easier ones, but when things are a little harder, I will go straight to this. That's just, you know, personal.
Wait. So we could either do all that or complete the square.
Yes, but
Oh.
but remember, completing the square might be hard, right? Because you might have fractions and you might have decimals and you might have weird things, right? But so now let's understand how this works. If this is my formula, y is equal to ax squared plus bx plus c. So let's say I give you a problem like this. Y is equal to 2x squared minus 4x plus 6. Well, let's see. Let's say it's plus 7 because then we won't have to divide it by 2. All right? Yes.
It's kind of ingenious, actually, because you can just plug everything in, and it'll be a lot more simple.
Yeah,
It's like
exactly.
having to-
That's all you're going to have to do. Is you have to figure out, though, what is your A, your B, and your C? What is my A in this equation?
2.
A equals 2. So I actually write it down. I write A equals 2. What's my B?
-4.
Yeah, and I write B is equal to -4. And what's my C?
7.
7. Okay. So now I go right here. X equals.
Should we start taking notes?
Now, oh yeah, now is
Oh
time.
wait, I took all those notes.
That's perfect.
Okay.
So now if you haven't taken notes, write down the quadratic formula. And this is an example that we're doing. I know the bell's going to ring any second, which is a bummer.
We should have a double block of math one day, Gary.
I know.
Yeah.
It would help a lot. But I don't want to kill you
We
guys
did
either.
one time, but that was just.
Sometimes one block is about all people can handle. So
So this is gonna be our homework tonight.
this is the homework. Is actually going to practice doing a few problems using this, okay? So you all understand how to find your A, B, and your C, right? Now you have to plug it in. X equals negative B, but B is -4. -4, it's +4, right? You see that? -4. Because the formula says negative B, and B is a -4, so -4 is +4. Plus or minus the square root of B squared, which is, what's -4 times -4? Positive 16. You'll notice this is always a positive number because you're squaring it, right?
Oh, okay.
The
So we don't
16.
need to do all the writing before we just got the quadratic formula.
Right. And I'm just,
Plug in the
I'm
thing this
I'm
way.
plugging them in, right? So -4 squared is positive 16. Now this is where people mess up. This next part. This is where you do not do stuff in your head, okay? You do -4, and you do parenthesis A is 2, and parenthesis C is 7. This is where people mess up. That's the only dangerous place in this formula. So you don't do any of this in your head. You write it out exactly. And then over here is 2 times A is 2, right? So that's 4. Okay, so now you have to just simplify, right? So suddenly you got X is equal to 4 plus or minus the square root of, let's figure this out, 16. Now notice this is a minus and all these are positives. So wouldn't you agree with me this is going to still be a negative number, right? The problem is sometimes these will be a negative number in here as well. And that would make it suddenly positive, right? You see what I'm saying? It'd be plus. And in this case, it's going to stay minus. So we got to figure this out. 4 times 2 is 8, right? 8 times 7 is 56. So suddenly minus 56. Immediately, what do you notice under the square root sign?
It's gonna be a negative.
So what's the answer? No solution. You're done. You just figured it out. This is a negative number. You can't have the square root of a negative number. Therefore, the answer is no solution. That just means that the parabola never crosses the x-axis. It just,
Wait, so Gary,
I don't even have to go further. I could put my 4 here, but I know that's going to be 16 minus 56 is negative something. Negative 40, right? You see what I'm saying? Now, if it had been, let's say this one was plus, let's say this was -7, just for a second, all right? Let's say I changed it to -7. Suddenly, this would be plus 56. Do you see that difference? And then suddenly, it would be 56 plus 16, 72, right? Square root of 72, right? So just practice with it, okay? That's all I'm asking is I want you to just practice a little bit. Get used to it, and you'll start to see how it works, okay? The hardest part is simplifying once you